Hey everybody, we are the Professor's Do Boys. Thanks for tuning in. Today, in this video, we're going to talk about the subatomic particles that make up an atom.
Woo! All right, let's do it.
Let's get started.
I love it. Here we go. We are going to start with... We're going to talk about how all matter is made up of atoms. So the atoms of the elements on the periodic table. Now an atom is the smallest amount of an element that retains the properties of that element. So the element copper, the smallest piece of copper that still acts and behaves as copper is an atom. If you break it down further, we call it subatomic particles. So let's talk about those.
You probably know these already. Subatomic particles, meaning kind of what makes up the atom, below the atom. So if we broke an atom apart, the particles we'd find, there are three that we're going to talk about. Now, some of you probably said, hey, you know, there's more. We can go further, but in general chemistry, we're just concerned with the proton, neutron, and electron. These are the three subatomic particles. We're making it easy. We like to make learning chemistry easy.
Mm-hmm. All right, now where are these located within the atom? The center of the atom there's something called a nucleus, and the protons and the neutrons are located there. The electrons are located outside of that. We also want you to know what the charge on those particles are. A proton is positive, a neutron is neutral, and an electron is negative.
So the protons determine what the atom is. We can do this by looking at the number of protons in the nucleus. So they call this the atomic number, and our periodic table is arranged by atomic number. And you can find the atomic number on your periodic table, and this is equal to the number of protons. So hydrogen in the upper left of the periodic table has a 1 on it. You can see right above the hydrogen on this particular periodic table, and sometimes that's moved around. It has a number 1, that means the atomic number is 1. There's 1 proton in hydrogen. Looking to the upper right, we've got He, that's helium, and that has an atomic number of 2, meaning that there are 2 protons in the nucleus of a helium atom.
All right, so you can't change that number and be the same element, okay?
And you can always find the number of protons for an element if you have your periodic table.
That's right, you should always have your periodic table. All right, the mass of an atom is in the nucleus, so pretty much all of that mass is contained within the nucleus with protons and neutrons. So if you take a look at the masses of these in grams, you can see that they're very, 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 very small, times 10 to the negative 24th and times 10 to the negative 28th. Also, I want to point out that the neutron and the proton are very similar. So 1.67 times 10 to the negative 24th grams. Now these may look like they're very similar, times 10 to the negative 28th and times 10 to the negative 24th, very, very, very small, but it's actually 10,000 times different. So it's 10 times 10 times 10 times 10. That's the difference in that exponent, or 10,000 times. So this is the difference between 100 pounds and 1,000,000 pounds. So this is the difference between, say, your luggage and the airplane that you're on. So the mass difference between your luggage being on this aircraft and not is negligible. So we actually say that the mass of the electron as relating to the entire atom is pretty negligible. So all of that mass is contained within the nucleus.
So these numbers are rather cumbersome. And I just want to go back and emphasize, that electron does have mass,
Yep.
But it's much, much, much smaller than the mass of a proton or a neutron. So again, making chemistry easy, we're not going to use grams. We're going to use a different unit called an atomic mass unit. And we're going to say that one proton is equal to 1 atomic mass unit. 1 neutron is equal to 1 atomic mass unit. And the electrons, we're just going to say they're negligible. So they're not going to count when we get the mass of an atom.
All right, so mass number, we're going to introduce mass number. So if we add up all of the protons and the neutrons, we would have a mass in AMU. Now, if you have an element, you know the number of protons from the periodic table. It's always the same. So if you are given the mass number, you can figure out the number of neutrons. And if you are given the number of neutrons for that atom, you can figure out the mass number. So let's give it a try here. So if we have a carbon atom with a mass number of 14, if we look on our periodic table for carbon, our atomic number is 6. That means we have 6 protons. So if the mass number is 14, we must have 8 neutrons. And the elemental notation for carbon can be written in 3 different ways here. For the isotope, we're going to talk about isotopes next lecture. The isotope for carbon-14 can be written in these 3 different ways. So the element symbol capital C designates carbon. The -14 gives us the mass number. The second one down has a 14 in the upper left. That's the mass. So you can have the element symbol and then the upper mass. The mass is given in the upper left. The lower 6 is the atomic number. So the only difference between the second one and the third one is that 6 is missing. Well, remember that carbon is always 6 number of protons. So that's really redundant. So oftentimes we just kind of make it easier and just write the mass number.
I used to get confused when I'd see these, especially if they gave me 2 numbers. But here's what you want to do. Go to your periodic table, find carbon. You'll see the atomic number is 6. So you'll know, okay, 6 protons. That 14 must be my mass. Here's one for you to try. Pause the video and see if you can do this on your own, and we'll give you the answer in just a few seconds. The answer is 56 AMUs. So where I start with this is I find iron on my periodic table. The symbol is Fe, and I see that it has 26 protons. So the atomic number is 26, meaning we have 26 protons. I add that to the number of neutrons to get the answer, the mass number in AMUs.
Yep, it's that simple. All right, so we've noticed that our number of neutrons can vary. And we're going to go into in depth in that in the next video. Your number of electrons can also vary. Now remember, electrons are negative. If we always have the same number of protons, we always have the same number of positive charges. But our electrons can be lost and gained, and that will change your charge. Electrically neutral elements have equal number of protons and electrons. So when you look on your periodic table and you see the number of protons in a neutral atom, your electrons will also be the same number as your atomic number. If you create an ion, that means that an electron was either lost or gained. An anion has gained more negative electrons, so that gives an overall negative charge. We call it an anion. Well, probably not because of this, but we can remember the term anion from a negative ion. Cations are positive, and they have lost negative electrons, but they retained all of their positive charges in the nucleus.
Now this sounds really confusing, but it's really not, and I'll show you what to look for. On this slide, we have the common ions. Now the charges will be written in the upper right. So if you have an ion, and that's just an element with a charge, that'll be noted in the upper right. And you can see here that it isn't always a positive charge. You can have a negative charge. You can have a 2- charge, meaning you gain 2 electrons. And these are the common ions that
we'll be working with.
And these are the ions that these elements like to form, really.
Sure.
So
we're going to learn why they like to form them as well.
And below we kind of show how lithium, when it's neutral, you wouldn't see anything in the upper right. That means it's neutral, which means the protons and the electrons are the same amount. We know the number of protons from the atomic number. Now this ion has lost an electron. So now we have 3 positives from the protons and only 2 electrons. And that net, or the result, is a plus.
And notice we have some commonality in these columns. So all of the first column, they're all positive 1. The last column, all -1. So you see some trends here, and those are good to know. And we're going to learn about why they have these common trends.
What about these that have more than 1?
Yeah, look at that. So chromium, Cr, has a +2 or a +3. And we call these polyvalent elements because they can form more than 1 ion. Many just form 1 ion, that's all they do. But others can have more. There are more polyvalent elements than are listed on this chart, but these are the ones that we're going to be using in this course.
All right, so we've got a little challenge for you guys. We've got a table here that there's enough information to completely fill out this entire table. So this is your challenge. We want you to pause the video and give this a try. We're going to put the answers up in just a second.
So each of these columns is an individual atom or ion. So it's in columns.
And here are the results, and we did a couple different element notations across the top. You could have written them, the boron you could have written as B-11. That is correct. But here are your answers.
All right, thanks for watching. We are the Professors Du Bois, and we are making learning chemistry easy.
So stay tuned, because in our next video, we're going to talk about those isotopes.
Isotopes.